What if the universe has been shouting answers at us all along, and we simply fail to hear them? At the same time, we have begun to uncover colossal structures, galaxies and planets, that by all our previous theories simply should not exist so early in cosmic history. This is not just a matter of finding a few outliers. It is as if the universe is challenging us to rewrite the textbooks we once trusted so deeply. Consider the early 20th century, when astronomers like Percival Lowell believed they saw canals on Mars, features they thought might be the handiwork of intelligent beings. These ideas captured the public imagination, but ultimately proved to be illusions created by the limits of our technology. The lesson was humbling. Sometimes our eyes and instruments deceive us, and the universe keeps its secrets cloaked in noise and ambiguity. Now, that fog of doubt is finally lifting. Today's telescopes, especially the James Webb Space Telescope, are not just glimpsing distant worlds, they are analyzing the very air of alien planets. They search for telltale chemicals like methane and oxygen, substances that, on Earth, always mean life is present. Each of these molecules acts like a beacon in the darkness, a chemical fingerprint that could be the signature of something living and breathing. For centuries, humanity has gazed outward, haunted by a question as old as curiosity itself. Are we alone? Our hopes clung to blurry photographs, ambiguous radio signals, and the faintest hints from distant telescopes. We debated every shadow and anomaly, desperate for proof, but left only with more uncertainty. The possibility of life beyond Earth seemed always just out of reach, a mirage that retreated with every attempt to approach it. So, what has truly changed? And how does this new evidence force us to question everything we thought we knew about our existence among the stars? The answers begin with the new eyes we have turned to the sky, and the game-changing data now streaming in from the James Webb Space Telescope. But now, that comforting story is unraveling, and the truth is far wilder than anyone dared imagine. Here is the astonishing shift. These findings are no longer isolated or accidental. Instead, a flood of discoveries is revealing repeating patterns, as if the universe is deliberately scattering clues in every direction. Life, structure, and complexity may not be rare accidents. They may be the rule, hiding in plain sight. If we ignore these signals and cling to outdated beliefs, we risk remaining blind to the true nature of reality itself. The universe is not empty or silent. It is alive with possibilities we are only just beginning to recognize. Failing to adapt could mean squandering generations on flawed ideas, missing encounters with life, and misjudging our own place in the cosmic story. For most of human history, we pictured the universe as vast, silent, and slow to change. A dark ocean where galaxies appeared only after eons of cosmic drifting. Ancient cultures, from the Babylonians to the Greeks, mapped the heavens and found patterns. But the true nature of those distant lights remained a mystery. The cosmos seemed immutable, a grand clockwork set in motion by unknown hands. Our best theories insisted that galaxies should be late bloomers. The early universe, they claimed, was a seething fog, too hot, too chaotic for anything but scattered hydrogen clouds. Yet then astronomers discovered MOMS 14, a fully formed galaxy blazing just 280 million years after the Big Bang. By every rule we trusted, such a galaxy simply should not exist so soon. And MOMS 14 is not a fluke. The James Webb Space Telescope keeps revealing more ancient galaxies like it, not crude, half-built structures, but surprisingly mature and organized systems. These galaxies appear shockingly early, defying everything we thought we knew about the pace of cosmic assembly. Let us put that in perspective. 280 million years may sound vast, but compared to the age of the universe, over 13 billion years, it is the cosmic equivalent of an infant's first breath. Imagine if you found an old-growth forest where only a barren volcanic plain should be. That is the scale of the surprise. But the surprises are not confined to distant realms. The evidence for a stranger, more crowded universe is coming closer to home, and it's about to get even more unsettling. How can this be? Some scientists argue that stars must have ignited much faster than our models allowed. Others suggest dark matter might have played a stronger, earlier role, sculpting galaxies out of chaos with startling speed. And a few propose even more radical ideas. Maybe the laws of physics were different back then. Or perhaps time itself flowed in ways we can barely comprehend. Consider the historical parallel of Copernicus and Galileo, when they challenged the geocentric model, insisting that Earth was not the center of the universe. They faced resistance and skepticism. But their willingness to question the prevailing wisdom sparked a revolution in science. Today, we stand at a similar crossroads. The evidence from Webb is as disruptive as the first telescopic glimpses of Jupiter's moons. If these early, sophisticated galaxies are real, and every fresh observation says they are, then our entire timeline for cosmic evolution could be wrong. That means everything from the birth of stars, to the formation of planets, to the possibility of life must be reconsidered. The stakes are enormous. If our models are flawed, we risk searching for answers in all the wrong places, and misunderstanding our own origins in the cosmos. The next discoveries are not only rewriting textbooks, they are forcing us to confront possibilities we never expected. What if the cosmos is teeming with signals and structures we have only just begun to see? What if the first undeniable sign of alien life is not buried in Martian soil, but unfolding right now in the clouds of a distant ocean world? For decades, humanity's quest for life beyond Earth crept forward, slow, careful, hedged by doubt and maybes. That era is ending. Today, the search has crossed a threshold. We are no longer just gazing at faraway planets with wishful thinking. We are gathering hard data, finding signals that cannot be ignored. Imagine the significance if a probe explored the clouds of Venus and found chlorophyll, a molecule essential for photosynthesis on Earth. That would be a seismic shift. The detection of dimethyl sulfide on K218b carries similar weight. It is a chemical that, as far as we know, only life produces in such quantities. Consider K218b, a planet orbiting a cool red dwarf more than 120 light-years from Earth. The James Webb Space Telescope has detected something astonishing in its thick atmosphere, dimethyl sulfide. On our own planet, this gas is only made by living organisms, mainly by tiny phytoplankton in the oceans. The odds of it being produced through volcanoes or chemistry alone are vanishingly small. Yet the story grows stranger. A second round of observations found dimethyl sulfide levels up to 1,000 times higher than anything ever measured in Earth's air. No known natural process explains numbers like these. If confirmed, this is not just a hint or a hope. It is the strongest, most testable evidence for alien life ever seen. A biosignature so dramatic, it points to more than single-celled organisms. It hints at a vast, active ecosystem hidden under hydrogen-rich clouds, shaping the planet's atmosphere on a global scale. The stakes are almost unbearable. It is not just about whether we are alone. It is about the credibility of science itself. If we dismiss these signals, we risk wandering in circles for decades, blind to the real signs of life, clinging to outmoded models, and missing our chance to understand the cosmos and ourselves. This discovery does not just rewrite one chapter. It may upend the whole story. By decoding faint starlight, we're forced to consider that life is not a cosmic fluke, but a common outcome, woven into the fabric of the universe. Accepting this would change the direction of science, redefine how we search for biosignatures, and force every one of us to confront the idea that we are not unique. To grasp the magnitude, recall how, in the 1970s, the Viking landers searched for life on Mars by looking for chemical changes in soil. Their ambiguous results haunted astrobiology for decades. But the evidence from K218b is far less ambiguous. If further studies confirm it, scientists might one day compare this moment to the discovery of penicillin, an unexpected find that changed the course of human knowledge forever. But the evidence, as extraordinary as it is, demands extraordinary scrutiny. Before we rewrite the textbooks, we must probe every possible explanation and face our own doubts. If the universe refuses to obey our rules, what else have we overlooked, both in the depths of cosmic history and right here at home? Each fresh discovery is upending the boundaries of what we thought was possible. Consider Julong, a spiral galaxy, eerily similar to our own Milky Way, yet glimpsed at a moment when galaxies should have been formless and chaotic. According to every trusted model, the early cosmos was a violent, unsettled place. Yet here we see order, calm, and perhaps even the gentle stability that life itself needs, billions of years before we thought it could emerge. If galaxies like Julong formed so early, then the ingredients for life, stable stars, enduring planetary systems, quiet cosmic neighborhoods, may have appeared far sooner than anyone dared to predict. This throws open a cosmic door. If order has existed since almost the beginning, could life have started long before Earth's story began? Perhaps civilizations have already risen and vanished, their histories lost before our planet even cooled. Let us imagine a scenario on a planet orbiting an ancient star in a galaxy like Julong. Life emerges, flourishes, and even develops intelligence. Over hundreds of millions of years, this civilization learns to manipulate its environment, perhaps even ventures into space. But cosmic cataclysms, supernovae, gamma-ray bursts, galactic collisions wipe out their achievements, leaving no trace. When Earth is still molten, their ruins are already dust. Could such histories have played out countless times across the cosmos? But these revelations are not limited to the distant universe. The James Webb Space Telescope has turned its attention closer to home and found Neptune, cold, blue Neptune, harboring secrets that defy every current theory. Webb has spotted intricate auroras swirling at its poles, abrupt temperature changes with no clear cause, and a cocktail of unexpected chemicals in its skies. These are not minor oddities. They are signs that our understanding of our own solar system is deeply incomplete. But raw data is only the beginning. The real test lies in how we respond and whether we dare to truly rethink everything we believe. We are not simply searching for answers anymore. We are learning to listen as never before. If the universe is stranger than we ever imagined, what concrete steps should we take next? It is time to ask what these revelations mean, not just for science, but for us. The danger is clear. If we cling to outdated theories, we may miss the biggest clues to life, overlook vital evidence about our origins, or squander decades chasing models that no longer fit the universe we actually inhabit. Science only advances when it adapts, and right now, the cosmos is not whispering. It is shouting for us to notice. For example, scientists detected carbon dioxide ice clouds high in Neptune's atmosphere, a phenomenon never before observed and not predicted by models. Such surprises echo the discovery of geysers on Enceladus, Saturn's icy moon, where plumes of water vapor suggest a hidden ocean and perhaps a habitat for life. Each unexpected finding tells us that the familiar is not as well understood as we believed. The true power of the James Webb Space Telescope is not in confirming our comfortable beliefs. Its greatest gift is showing us where our assumptions collapse, where the universe refuses to obey our tidy models and convenient explanations. This is not just a matter of gathering impressive data. It is a challenge to the very way we discover. Instead of searching for confirmation, we are being called to notice what we missed, to recognize biases we never questioned. Webb's lesson is clear. The cosmos was not designed to validate our theories. Instead, our theories must adapt to the wild reality before us. Each time Webb catches something unexpected, a whiff of unusual molecules in the clouds of a distant world, a spiral structure in a galaxy that should be too young to form one, it forces us to rethink our questions. We are pushed to imagine further, to stretch beyond the boundaries of our old, safe answers. The familiar ground is gone. The universe will not fit inside the boxes we built for it. For most of the past century, we pictured a cosmos that was mostly silent, mostly barren. Life and structure, we thought, were rare exceptions, a quiet backdrop with only a few sparks of meaning. But now, with Webb's revelations, that illusion is shattered. The so-called silence is gone. In its place, we find a universe crowded with signals, intricate patterns, and the tantalizing possibility that life and complexity may be far more common and ancient than we dared hope. If we cling to outdated models, we risk missing the next great leap. The universe has been broadcasting its secrets all along, but only now do we have the tools and perhaps the humility to listen. If we ignore these signs, we could spend generations chasing illusions, letting the true origins of life and structure slip by unnoticed. This is how science truly advances, not by defending the old certainties, but by asking what else becomes possible when we let the universe surprise us and when we are brave enough to listen. If everything we thought we knew is upended, what comes next? The real journey begins when we let go of certainty and follow the signals wherever they lead. We are no longer alone in the darkness, and the universe is not slowing down to let us catch up. Every spectrum, every image, every puzzling anomaly delivered by Webb is more than just a headline. Each is an invitation. Each disrupts our comfort and demands that we redefine what it means to explore. The real power is not only in the answers we find, but in the new questions we dare to ask. To ignore these signals, to retreat from the challenge, is to turn away while the universe rewrites itself without us. If we refuse to adapt, we doom ourselves to irrelevance, trapped inside old stories and obsolete frames of reference. The patterns are forming whether we acknowledge them or not. The silence we trusted is gone, replaced by a chorus of mysteries. If we cling to familiar models and easy answers, we risk squandering the most profound transformation in human understanding since the dawn of science. This moment is not about correcting a few mistakes or nudging a timeline. It is about realizing that life, complexity, and cosmic structure might be ancient and widespread, far beyond what we once dared imagine. Now is the time to welcome uncertainty, to question even our most treasured theories, to nurture a curiosity that is relentless and brave. Because every time we peer further, the universe grows stranger, and in that strangeness, we find our greatest chance to grow. The revelations from the James Webb Space Telescope have fractured the illusion of an empty, silent cosmos forever. With every new glimpse, every improbable galaxy, every unexplained glow, every strange signal flickering on a distant world, we are forced to confront the collapse of our oldest certainties. The universe has become unruly, unpredictable. Our place inside it is more enigmatic than ever before. What unfolds now is not the closing of a chapter, but the ignition of a revolution. The questions we dare to ask today will define the answers we may reach tomorrow. Remain open, remain skeptical, remain curious. In this new age of discovery, the gravest mistake is not being wrong. It is refusing to wonder what might be right. Historically, revolutions in knowledge have always followed periods of uncertainty and humility. The Enlightenment only happened after the old certainties of medieval cosmology collapsed. Darwin's theory of evolution emerged from decades of comparative observation and the willingness to discard cherished beliefs. The current era, with its flood of Webb data, is our own turning point. For example, imagine a new generation of robotic explorers, equipped not only with cameras, but with advanced chemical sensors, dispatched to every corner of our solar system. Imagine open-access astronomical databases, where anyone, student or amateur, can hunt for anomalies and patterns missed by professionals. Consider international agreements to share telescope time and data, so that discoveries are not bottlenecked by nationalism or bureaucracy. Each of these steps brings us closer to a science that is as dynamic and unpredictable as the universe it seeks to understand. The practical steps now are clear, even if they are daunting. Scientists must double down on interdisciplinary collaboration, pulling together astrophysicists, chemists, biologists, and even philosophers to interpret the strange new signals pouring in from space. Funding agencies, often slow to change course, must be willing to support bold, unconventional research that challenges the orthodoxy. Meanwhile, educators and communicators should invite the public into this process of discovery, fostering a culture where it is not only acceptable but celebrated to admit that we do not have all the answers yet. So, as we stand at the edge of this new cosmic frontier, let us keep our eyes open, our instruments tuned, and our minds supple. The universe may always be one step ahead, but that is precisely what makes our quest worthwhile. And yet, the journey is not only scientific, it is deeply human. As we confront the likelihood that life is not unique to Earth, we are called to reconsider our ethics, our philosophies, and our sense of meaning. We may discover that the greatest lesson is not about the universe's abundance, but about our own capacity for wonder and adaptation. The question is no longer, are we alone? The question is, are we ready to listen, to learn, and to be changed by the answers the universe is finally shouting our way?